Well, hello there everyone. My name is Ratra and I am currently pursuing a B.Tech in Engineering Physics from IIT Roorkee. Today, we will be doing a short presentation on the usage of electromagnetic pickups in musical technology. So as you can see, this instrument right here is an electric guitar. Now, how does an electric guitar function and how is it different from an acoustic guitar? Okay, first of all, an acoustic guitar, if you remember, is a six-stringed instrument which relies on a hollow body to amplify the sound produced by the vibration of the strings. Okay, but this instrument is a solid body instrument. Okay, which basically means that if I play this instrument without connecting it to any speaker or any sort, we get an output which is really low in volume, and hence you cannot play this thing without connecting it anywhere. Okay, so what does all the magic? The answer is this electromagnetic pickup. Okay, once it is connected to an amplifier and we play it, we get some audio output. Okay, now the question is, how does this exactly function? So first of all, I know what you guys may be thinking. No, this is not a microphone. If I snap my finger in front of it, you can clearly see that there is no audio output. Okay, however, when I pluck a string, you see that it gets sensed and the output is reflected in whatever sound source I'm using. Okay, so how does this exactly function and what is happening inside, how we design these pickups, how they function, what is the mechanism behind them, and how can we add design improvements to them, we will be seeing that in today's presentation. I hope you enjoy the video. Hello there guys, so here is a brief overview of what we will be going through in this presentation. First, we will introduce ourselves to electromagnetic transducers and electromagnetic pickups. Then we will go through the working and construction of the same. Then we will go into further classification and design improvements and also try to delve into further innovations made. And then we will ask ourselves, can we do something better than this? So let us go ahead with this presentation. So a transducer, in simple words, converts one form of energy into another. In this case, we are interested in electromagnetic transducers, which converts mechanical motion into electrical impulses. We rely on the principle of electromagnetic induction, and hence, this falls in the class of inductive transducers. These are sensitive to changes in magnetic flux, hence inducing an internal current. In this animation, you can clearly see that the mechanical motion of the magnet causes the current to be induced in the coil. As per Lenz's law, the current induced is such that the magnetic field produced by it is in the opposite fashion to what causes it. Hence, we use this principle to measure motion without any contact. This principle is employed in devices including LVDT, which is used to measure displacement. However, in this presentation, our focus is on a specific application, that is, to detect the vibrations of a string. Okay, so in a way, yes, we can say that the principle of electromagnetic induction is responsible for the emerging of various iconic artists such as Slash, Jimi Hendrix, Eric Clapton, John Mayer.
कुछ भी
Alright, so now let us have a quick look at the parts of the guitar. We have the standard parts like the body, the bridge, the headstock, the neck, the frets, etc. But we also have these things right here. These are called pickups, okay? So an electromagnetic pickup is a transducer which senses the mechanical vibrations of the string and converts it into an electrical signal. This signal further undergoes further conditioning and amplification before being output in the form of sound. We use this principle for various instruments, mostly guitars, but also other string instruments such as violins, cellos, etc. also use this principle. Alright, so now let us have a quick look at the construction of this pickup. So the simplest construction is that of a single coil pickup. This consists of a bunch of cylindrical magnetic pole pieces and a fine copper wire wound around them, of course with proper insulation and framework to ensure that the components remain intact. The mechanism is described in the diagram and shown in the animation. The string is mostly made of a ferromagnetic material, mostly steel is used and the lower strings are normally wound with nickel or cobalt, and hence the field generated by the magnetic pole piece will magnetize the string above it, and hence the string will have its own magnetic field. Okay. So when there is a vibration of the string, there is a change in a magnetic flux which will result to a current being induced in the coil. The current induced carries the information about the frequency of the vibration. What I have just described can be seen in the animation in the figure above. The signal thus produced goes through various manipulation stages, such as amplification, distortion, delay, compression, filtering, etc. This can be done through analog means as well as digital means. Analog means involves usage of multiple effect pedals and amplifiers as shown in the first figure, which consists of multiple, in fact too many pedals connected in series on a pedal board. The same effects can be achieved digitally using an effects processor which replicates the effect of all of these pedals in series in just a single unit. Initially, analog pedals were more popular, but nowadays, due to ease and comfort, digital effects are in more popular use. So it was all good till now. Now let us discuss what are the issues with this type of pickup. So our electromagnetic pickup is in fact susceptible to electromagnetic interference, which is brought about by other electrical devices nearby. This can cause a lot of buzzing and humming noise to come up from the pickup, okay? And with further high gain effects such as distortion, etc. being applied on the signal, there is a chance that the noise itself is amplified and hence the resulting sound is not very good, okay? There are other issues such as limited strength, resonance feedback, and also the lack of a low end response. Now my friends, we have encountered a barrier to cross. What improvement can we make to this existing design, such as the external electromagnetic noise is minimized or cancelled without having to worry about the overall signal quality degrading? What is the answer to that? So an easy answer to this question is to just add another coil to it. Now some of you may have this reaction.
कोई सेंसर बात की?
जी हाँ, complete sensor. What we do here is that we take two pickups with coils of opposite winding and magnetic pole pieces of opposite polarity, and we connect both of them in series so that the signals coming from both are added. What do we see here? Whenever there is any noise due to electromagnetic interference induced in both the coils, since the coils are already wound in an opposite manner, the resulting noise will be out of phase in both of the pickups, and hence when they both add, effectively the noise is cancelled. But what about the signal due to string vibration? While the second coil already is in opposite winding, the polarity of the magnet is also opposite. So there is a double phase reversal of some sort. Hence the guitar string vibration produces both signals in the same phase in both of the coils, and hence their addition gives a stronger signal. Hence we get a strong signal with minimal noise, and hence a very high signal to noise ratio. This is done without affecting the quality of the tone at all. This type of pickup is referred to as a humbucker, since it literally bucks the hum. This is what an actual humbucker pickup actually looks like. We actually use a trick here. We use a single Alnico magnet here, which has its own north and south poles, to effectively have the pole pieces for both the coils to be of opposite polarities. The rest of the construction is just to keep everything else intact. Hence, there are a lot of advantages to using a humbucking pickup instead of a regular single coil pickup. We have already cancelled out the noise and increased the tonal qualities. We are also able to have a more warm and deep tone and a wide range of tonal options. We observe a wider frequency response and a better low end response as well. This pickup also allows for more consistent tonal output across the strings. Some guitarists prefer to also use single coil pickups just because it has a more vintage tone, but the tone from the humbucker is sort of more refined. Okay? Now let us get into further territory and explore other innovations done in this area. First here we have active pickups. Till now we have been talking about passive pickups, which do not require any external source to function. However, the signal strength we get at the output is far too low. The solution to that is switching to active pickups. These are devices which use an inbuilt power source, most probably a 9-volt battery, but in addition they allow for tone shaping, preamp, and noise reduction through onboard electronics. This allows for good signal amplification before the effects of cable noise kick in, hence increasing the signal to noise ratio further. Another class of pickups include piezoelectric pickups. They are widely used in acoustic instruments. We all know that piezoelectric crystals are used in devices such as microphones and watches, and these respond to changes in mechanical pressure and they give response in the form of electrical signals. Since sound itself is a pressure wave, it is picked up by the piezoelectric crystal. These pickups are not susceptible to electromagnetic interference and also allow us to preserve the timbre of the sound. Okay, hence these pickups are used to amplify the sound of acoustic instruments like acoustic guitars, mandolins, ukuleles, violins, etc. They are used more frequently when the natural sound coming from the instrument is what we aim to amplify. Now let's dive into some experimental territory with optical guitar pickups. These are not mainstream yet, but are fairly easy to understand when it comes to the fundamental idea. An optical pickup uses variation in light intensity to develop pulses. They can be operated in different modes. In transmissive mode, we basically sort of track the shadow of the strings relative to the ambient light to figure out what the frequency of vibration is. While in reflective mode, we have a light source of our own, and hence we reflect that light of the strings and use that reflected light to track the motion of the string. There are some easy issues to identify with this type, such as sensitivity to ambient light conditions, etc. And that is probably why these pickups are not in mainstream market yet. Now let us talk about electrostatic pickups. What are we doing here? We initially dealt with inductive pickups. Now let us talk about a different setup, that is that of a capacitor. We all know that the capacitance of any capacitor will depend on the distance between the two plates. If we are talking about a parallel plate capacitor, the distance between the two plates, we know C is equal to epsilon naught times A by D. So it's an inverse relation. So this tells us that the capacitance is very sensitive to displacement. So we keep one plate of the capacitor fixed and the other free to move and vibrate. So hence this can be used as a tool to measure the frequency. And hence, due to the above reasons, we know that capacitive transducers are very sensitive and hence provide a more dynamic range as compared to inductive transducers. This type of pickup is not very frequently used in guitars but have been used in the past in organs and pianos. The picture here is in fact of the Wurlitzer, correct me if I'm pronouncing it wrong, but the Wurlitzer Model 44 electrostatic reed organ, which uses this particular type of pickup. Okay, now back to some familiar territory. Now this is just an interesting innovation, that is polyphonic pickups. They are like single pickups for each string. That is, we've got 6 coils or 6 windings, each for each string. So there are 6 lines of output here. This type of pickup allows for different volumes for different strings, and they are mostly used for the purpose of MIDI transcription of guitar parts for songs, etc. Okay, we can think of similar constructions to even build stereo pickups as well. Now that we are approaching the end of this video, there are some questions that I want you to think about. Okay, what if we are using multiple types of pickups and we somehow try to combine the signals from multiple types of pickups together? How do we do this to get a fruitful result, and what will that result be? And another thing to think about is, can we come up with some other better mechanism to employ in musical instruments? What are the other senses that we can think of that can be employed to the same purpose? So with this, we have